Hello everyone. In the previous video we have seen that how we can express force acting on a charged particle when it is moving in a magnetic field, that is known as magnetic Lorentz force. Now what we are going to do is we are just going to see how some of the rules can be used to find the direction of force in a very easy manner. Let us see how it is done. That is the rules for finding direction of force on a charged particle moving in a perpendicular magnetic field. Like the general formula we know that for force which we use here is for a charged particle moving with velocity v in a magnetic field B is given by F is equal to Q V cross V. Now V cross V, the cross product of these two vectors, the direction of cross product of two vectors is given by right hand thumb rule. We have to consider our right hand and we have to consider these curved fingers from V to B. Then the thumb will show us the direction of force. So that is what exactly we have to do. We have to take our right hand, we have to curve our curved fingers in such a way that it moves from V to B. Then F will be represented by thumb. This is the general formula or general way to find the direction of force. Now, in a particular condition, the condition which we are considering here is the magnetic field is perpendicular to the direction of motion of the charged particle. That is, V is perpendicular to B. So, if this is the case, you can see in the diagram it is mentioned here. As you can see, the magnetic field B is along y-axis. The velocity of the charged particle is along x-axis. And the force is along z-axis. We are considering a positive charge, and always remember one thing. Take it as a note so that it can be used anywhere. Like the direction of current is actually the direction of positive charges. The positive charges, the direction in which it moves is actually the direction of conventional current, because we know that the direction in which the electron moves is opposite to that of the conventional current. So always remember the direction of positive charges is the direction of current. So let us see the rules first. Two rules we are going to discuss here. The first one which we are going to discuss here is the Fleming's left hand rule. In this rule, you have to stretch the thumb and the first two fingers of your left hand. That is the forefinger and the middle finger. Thumb, forefinger and the middle finger. You have to stretch it in such a way that they are perpendicular to each other. Right? You have to consider it in such a way that they are perpendicular to each other. Now, if this is the situation where the forefinger, this is the forefinger, this is the middle finger, and this is the thumb. All these three fingers are mutually perpendicular to each other. Okay. Now, if the forefinger points in the direction of magnetic field, this is the direction of magnetic field. Forefinger represents the direction of magnetic field. And the middle finger or the central finger represents the direction of positive charge. This is the direction in which the positive charge moves. Velocity of positive charge, or just now I have explained, it is the direction of current. Then the thumb will give you the direction of force experienced by the charged particles. So, forefinger represents the magnetic field. The central finger represents the direction of the velocity of the positive charge or the direction of current. Then the force is given by the thumb finger. Thumb is the resultant where we get the direction of force. The condition is the magnetic field and the velocity of the charged particle, they are perpendicular to each other. I hope this is very clear to you. Once again I am repeating it. This is the direction of magnetic field. This is the direction of in which the positive charges move or the direction of current, and then the thumb finger represents the direction of force. In the diagram also it is shown here. We have magnetic field along y-axis, velocity along x-axis, so the force will be along z-axis. The diagram with the help of left hand is shown here. Forefinger represents the magnetic field. This is the middle finger or the central finger represents the direction of current or velocity of the positive charge. Then force will be given by the thumb finger, which is along z-axis. So I hope this is very clear to you. Now the next and another very simple rule which we are going to discuss here is the right hand palm rule. So this is your right hand. The right hand palm rule will be used, and this right hand palm rule, what does it says? Open the right hand and place it so that the tips of the finger points to the direction of magnetic field, the thumb in the direction of velocity v of the positive charge, then the palm faces towards the force. The finger is along the magnetic field, velocity of positive charge or the current is along the thumb, then the palm, the direction in which it faces represents the direction of force. This is the right hand I am taking. Now in this right hand, this direction of fingers represents the magnetic field. This represents the thumb finger. Direction of thumb finger represents the direction of current or the positive charges, the direction in which the positive charges move. Then the palm, it faces in this direction, so this will be the direction of force. Magnetic field, current or positive charges, and the direction in which the palm faces, this will be the direction of force. So any rule you can use the first one, in which we have considered the Fleming's left hand rule, then the right hand palm rule. So any of the rule can be considered to find the direction of force acting on a positive charge moving in a magnetic field, or the force acting on a current carrying conductor placed in a magnetic field. So I hope this is very clear to you. If there is still any other doubt, you can post me the doubts, and the doubts will be taken care of for sure.